Welcome, welcome. All right, shout outs to Algebra 2 students at MCHS. Let's do this. So, we're going to jump into Lesson 39, Factoring Extended to the Complex Realm. So, the big question is, if I were to say, let's factor x squared minus 4, this is just simply x plus 2, x minus 2, right? We did this a very long time ago. And if I said, let's factor x squared plus 4, in the real number line, this is not factorable, okay? But using I, it's possible to factor something like this, and I'll show you how, right? So what I'd like you to do is, if everyone has this paper, we're basically going to do these 3 questions and these 2. And what I'd like you to do is write your notes differently from what we do over here. Because everything we do over here, it doesn't have the nice questions where we can talk about. So here, what I'd like you to do is, on a separate piece of paper, have learning intention, essential question, questions, pause the video, have this set up, and notice that these 3 questions are the same exact thing over here. Okie dokie. So let's say you're coming back to the video. Let's just read the learning intention together. Here it says, students will learn how to solve and express the solutions to any quadratic equation. The EQ will be, how can we use I to factor polynomials that were considered unfactorable? Like here, how can we use this I to factor something like this x squared plus 4? Okie dokie. What I'd like you to do is, just to warm up, rewrite each expression as a polynomial in standard form. So here, all I want you to do is just FOIL this, right? Multiply this to this, this to this, this to that, this to this. You should be doing A and B nice and quick. C, I will work with you because C is a little tricky. You have to do something, okay? So pause the video and try and do these 2 by yourself and see what happens. All right? Let's say you want to come back to the video here. Let's FOIL this out. X times x is equal to x squared. X times minus I is minus xi. Here, next one, I times x is plus xi. And I times minus I is minus I squared. But then this is just equal to x squared. And remember, I squared is negative 1. So this just becomes x squared plus 1. And that's it. All right. What about the next one? Here, this should have been equal to x squared plus 25. Okay? And I'll let you figure it out. And now next one over here, let's try and do this one. If we look at this polynomial expression, here it says x minus 2 plus I, here x minus 2 minus I. And here, let's see, can we do anything in the parentheses? Can we add 2 plus I and 2 minus I? You can't. So what you could do here is have it look like this. All right. This is the same as x minus 2 plus I, and this is x minus 2 minus I. These 2 are exactly the same. And what you could think about doing is FOIL it now like this. What is x minus 2 times x minus 2? What is x minus 2 times minus I? What is I times x minus 2, and what is I times minus I? And now have it out like that. What I'd like you to do is pause the video and try and do it yourself. But here, if you want to see the solution, x minus 2 times x minus 2, that is x squared minus 4x plus 4. Right? Here, x minus 2 times minus I, whatever that is times whatever this is, cancels out. It cancels because it's a difference of perfect squares. And here you're going to have just a minus I squared. So now this just becomes x squared minus 4x plus 4 plus 1, and that's equal to x squared minus 4x plus 5. Okie dokie. If you have any questions on this one, raise your hand and I will show you. Raise hand. Okie dokie. Alright, so now that we did these 3 questions together, let's look at the next part. Here, notice that if this was equal to x squared plus 1, isn't x squared plus 1 equal to this x plus I, x minus I, right? Isn't it equal to each other? And same thing with that, this x squared plus 25, it's equal to x plus 5i times x minus 5i. So this is something to think about. Now here, let's look at question 1. Can we observe patterns in A to C? What kind of pattern did you notice? Here, can we generalize a pattern for something like this? And we absolutely can. So here, if you have some x plus ai times some x minus ai, this will be the pattern that's here, right? Don't we have some x plus ai and the coefficient of this a is 1? Don't we have this pattern here? And we also do have this pattern here, right? For this one too. And what would it be? What I'd like you to do is FOIL this out. And if you FOIL this, if we have some x plus ai times x minus ai, it should equal x squared plus what? Let's see, x times x is x squared. X times minus ai is minus xai. This is plus xai. And this is what? Minus ai squared. But minus ai squared, this will just be x squared plus a squared. Because here the I will just cancel out, because here we have I squared is equal to minus 1, and this will just become x squared plus a squared. And that's what's happening here. That if I have, let's say, x plus 7i times x minus 7i, this is simply just equal to x squared plus 49. Because we're taking that a and we're just squaring it. If you have any questions on this, just raise hand and I will show you. Okay? Now, what is happening here? What I'd like you to do is, having this pattern down, I'd like you to factor these using I. For example, the first one, if I have some x squared plus 9, this will equal x plus 3i, x minus 3i. Alright? What I'd like you to do is try and do some of the rest, and we'll talk about it. Okie dokie. And here, actually, you know what? Try and do it by yourself, and then we'll go over it together in the video. So here, this is the solution for the first one. The next one will just simply equal x plus 5i, x minus 5i, and we just did this right now, right? Here, this one is equal to x plus square root of 5 times x minus square root of 5. Because here, 9 is a perfect square, 25 is a perfect square, and 5 is not a perfect square. But here, once we did this, right? What's the square root of 9? It's 3 and 3. What's the square root of 25? It's 5 and 5. Here, you take the square root of 5, it doesn't have anything, so you just simply write it x squared plus square root of 5. For example, like let's say if I had x squared plus 8, 8 is not a perfect squared, so this can just simply factor as x plus, oh, oops, there should be a, we're missing something here. Oh yeah, there should be an I here. Sorry, there should be an I here, right? This should be x plus I root square root 4 times x minus I square root 4, okay? And these two are equivalent. Let's look at this one. Here, well, this one is not in this format, right? But we can simplify this. This is equal to x times x squared plus 4. And this is equal to x times, and now this we can factor now. Don't you remember that was the original question we had, that if we had x squared minus 4, it's equal to x plus 2, x minus 2. But x squared plus 4, we can factor it in the complex realm, and this is equal to x plus 2i times x minus 2i. Okie dokie. For this one, remember a long time ago where we had to factor this many times? This is equal to x squared plus 4, x squared minus 4. But then this x squared plus 4 factors to x, which we just did, which is x plus 2i times x minus 2i. And this is what? X plus 2, x minus 2. So this factors like this. And that is our solution. And I'll box it here. And this one here. What about this guy? 2x squared plus 1. How can we factor this one? This one will be, we will talk in class. Right? What I'll do is I'll have more examples for us to do in class, and then we'll go over it together. Okay, enjoy.